Back by popular demand, I am Gaston Mapala. Today, let's have a look at question 7 November 2022. It was a calculus question, and then the first question 7.1 was from first principle, where they wanted us to find the derivative from first principle for that f of x function. Second one was the derivative of that f of x function, and then the second one involved a cubic function where we have got a tangent and also a gradient, and we also have to find the values of x and give a comment whether it's concave up or concave down. Right, so now let's go ahead and deal with 7.1. 7.1, it's saying right here that it says the formulae. If you go to your formula sheet, you will see this formulae that says that lim as h approaches 0, you should have f x plus h minus f of x all over h. Okay, great stuff, all over h. And then I did say initially when we're doing the lesson on calculus that if they give you something like this and then they want it from first principle, what does this mean? This means that wherever there's x, you substitute x plus 1. So therefore, wherever there's x, you are going to substitute x plus 1. Okay, where there's x, or rather x plus 1, rather root x plus b, x plus 1. Okay, this is what that means. Lim, you keep writing it until the end. Okay, lim as h approaches 0, you need to write until the end. Okay, need to write this until the end. Okay, right till end. Okay, great stuff. All right, so let's go ahead and substitute here. Lim, you're going to say lim is h approaches 0. Okay, where there's x, we're going to put that. Okay, so from our equation there is x squared, so we're going to have x plus h, but it needs to be squared. Okay, and therefore we are going to have plus, what do we have there? It's x plus h. Great stuff. All right, so here we're going to have minus in brackets f of x, which is x squared plus x close, and then all over h. Okay, great stuff. So now what we're gonna write here, we're still going to write lim as h approaches 0. Try to take my time here, be as slow as possible. Okay, then we're gonna have to expand this here. Is going to be x plus h close bracket x plus h close bracket plus x plus h, therefore minus x squared minus x. All right, multiplied through by a negative there, all over h. Okay, therefore we continue to write lim until h approaches 0. As h approaches 0, we remove the bracket, we do binomial here. We remove our bracket, so we're going to have x squared plus xh, another xh, so it's going to give us 2xh, and then h times h is going to give us h squared plus, this will just give us x plus h minus, in this case you're going to have x squared minus x, okay, all over h. Therefore we keep going, let's keep going. H approaches 0, we'll keep writing it until we say h approaches 0, guys. If you leave it out, you are going to lose marks, so please pay careful attention to this. Minus x squared, positive x squared will disappear, then I've got a negative x there, and the positive x there will disappear as well. All right, So now what are we left with? We are now left with 2x h plus h squared plus h all over h. All right, I'm running out of space here, so I'm gonna continue this side, guys. H as h approaches 0. I'm going to have, I've got h there, h there, h there. Therefore, I'm gonna take h out as a common factor. So I'm going to here, I'm going to be left with 2x plus h. Oh, sorry. Then I think there's a plus 1 there. Okay, all right. Okay, great stuff. Okay, then yeah, then there's going to be plus 1 here after removing the common factor. Therefore, all over h, right? Therefore, h and h would cancel out. Then I'm going to continue up here, guys. H and h would cancel out. Therefore, I'm going to be what I will left with is lim as h approaches 0. I'm going to be having 2x plus h. Therefore, now as h approaches 0, I'm going to have 2x. Oh, sorry, I forgot the plus 1 there. Thank you, guys. Thank you for letting me know. Plus 2x plus 0 plus 1. Okay, so therefore our final answer will therefore be 2x plus 1. Okay, and that's how you would deal with 7.1. Let's go ahead and move to 7.2 and also 7.3. Okay, 7.2 says here f of x is equal to 2x to the power 5 minus 3x to the power 4 plus 8x. All right, they are requiring us to take the first derivative of this. We know with the first derivative formula, if you are given x to the n, is going to be, you bring the n down and it's going to be x n minus 1. Okay, so we are going to apply this onto this equation here. We're going to bring down the 5 is going to be 2. Okay, let me rather, yeah, it's going to be 2 times 5 for those that are still a little bit struggling. It's going to be x. 5 minus 1 is going to give us 4 minus 3 times 4 x. 4 minus 1, 3. Therefore here you are going to have a 1, then it's going to be 8, then it's going to be x to the power of 0. All right, therefore after simplifying this, this is what you're going to have. You're going to have 10 x to the power of 4 minus 12 x to the power of 3 plus 8, because anything to the power of 0 is equal to 1. And that's how you would deal with this question, guys, of 7.2. All right, great stuff. So now let's go ahead and come to question 7.3. 7.3, it's saying g of x is equal to ax to the power 3 plus 3x squared plus bx plus c. Right, okay, so what is the question saying? The tangent to this f has a minimum gradient at that point. So they give us a point there, a point of minus 1, minus 7, and then for which values of x will g be concave up. All right, so this is the point of inflection. Is the point of inflection. So let's go ahead and do this. We get the point of inflection when we are dealing with the second derivative. So let's go ahead. First derivative is going to be equals to 3a x2 plus, you bring the 2 down, is going to be 2 times 3 is going to be 6. Then for 2 minus 1 is going to be 1 plus, then you bring 1 down, b times 1, and then x to the power of 0 is just 1. All right, okay, that's the first derivative. Then you're gonna go ahead, taking the second derivative is equal to, you bring the 2 down, 2 times 3 is going to be 6, a, and then u minus 1 is going to be x, plus bring 1 down is going to be 6, and then 1 minus 1 is going to be 0, then x to the power of 0 is going to be just 1. So we get the point of inflection when the second derivative is equal to 0. There you go, we made it equal to 0 there. Okay, so now we're looking for x values. All right, so but we can't find the x values when we have got a values. So therefore the best thing to do is to say, all right, where do we get this point when x is equal to minus 1? All right, so we're going to come here and say substitute x is minus 1 plus 6 is equal to 0. Therefore we're going to solve for a. What we have here is negative 6a is equal to negative 6. I've already taken the negative 6 to the other side, so divided by negative 6, everything divided by negative 6, negative 6. Therefore a is equal to 1. All right, so therefore if a is equal to 1, we are looking for concave up. Okay, for which values where g is concave up. Okay, so g will only be concave up, if the second derivative is greater than 0. Okay, so therefore this means that our general equation will then have to be 6 plus that plus 6 greater than 0. All right, so you come here and then you solve for x. You solve for x divided by 6 divided by 6. Therefore x is greater than minus 1. Okay, so therefore it means this curve will be going up at x minus 1. So if it is drawn on a Cartesian plane like this, guys, therefore you have a minus 1 here at x. So therefore it means this curve is going to start to concave up like that. Right, that's what it means. I am Gaston Mapala right here at Maths with Gaston. See you on the next upload where we'll be doing question 7 of November 2021.